Challenger today had flown for just a little over a minute. When it left Cape Canaveral after something of a delay, it was a little after 11:30 in the morning. Let us go back now to recall that moment which much of the nation saw live and much of the nation shared in. The initial joy and the subsequent horror.
Space shuttle mission, and it has cleared the tower.
Now controlling program. Roger, roll, Challenger.
As you can see on your screens there, it was 11:39 in the morning Eastern Standard Time after yet another delay, and Challenger's had a number of them, as has had Columbia. But it looked so perfect against the blue Atlantic sky as the rollover came.
Engines beginning throttling down now at 94%.
And those big additional booster rockets in the main engine rocketed Challenger towards its orbit,
65% shortly.
roughly approaching 2,000 miles an hour.
Engines at 65%, 3 engines running normally, 3 good fuel cells.
There will be a phrase here that we shall all long remember. Listen to mission control,
Velocity
tell them what to do.
257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles. Engines throttling up, 3 engines now at 104%.
Challenger, go with throttle up.
Go with throttle up. And then it happened.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
And it occurred with such lightning speed as one of the booster rockets flies randomly off into space, and we look at it again in slow motion, that you may have noticed that the control commander, the launch control voice that we've become so familiar with on launches, was simply reading his telemetry, his information coming back, and was not aware, as so many people were when they saw it, even though they didn't understand it in space. Lynn Scher, who covers space for us on a full-time basis. Lynn, can you pick up from your base in California and tell us now what we're seeing?
Well, Peter, we've just gotten past, obviously, the critical moment. This is the fireball. This is the catastrophic explosion engulfing the Challenger and the solid rockets. And I think in just a moment, you will see the what we think there on the lower right of your screen appears to be Challenger's nose emerging from that big cloud, then falling into the ocean, our last view of Challenger. We have examined these tapes so many times, Peter, that we think we can at least try to pinpoint the sequence. At the right of your screen now, the solid rocket booster fizzling off into nowhere. Nowhere to go. It is controlled before launch, and it's meant, of course, to be attached to the shuttle and to the tank and to take them into orbit. But with that premature explosion, it has nowhere to go, and it's off into the ocean. And if I'm not mistaken, the next few frames will show us the crazy spinning of the 2 solid rocket boosters forming kind of an awkward Y-shaped as they each go off in kind of a cockeyed direction, obviously not where they're meant to be going at all. It looked to us, when we have screened this tape before, that the first flame appeared in between the external tank and the orbiter. Now that's the plume on the left. That's a little bit of the gas fuel for the fire, just the liquid hydrogen and oxygen burning off. There is where we thought we saw the first sign of flame. Actually, I think it was a little bit before this. Maybe we can go back and find that. In any event, this is the flame that is now going to ride up the external tank in between the tank and the orbiter, both of them extremely thin-skinned on purpose for weight reasons. They're not meant to withstand this kind of explosion, and obviously when that liquid hydrogen and oxygen gets near that kind of heat, boom, it just went in an instant. And no one I have talked to here on Earth believes that it happened in any more time than just an instant. The astronauts, the shuttle, simply did not have a chance.
And in other words, to not put too fine a point on it, they didn't know it hit them.
Absolutely not. I know that you and everybody were talking very hopefully for a while that perhaps those parachutes indicated they had gotten out. There really does not appear to be any way. That shuttle is simply not designed for that kind of explosion. Now, of course, the problem is what really happened. We can look at the sequence. We can pinpoint where we see the flames. What NASA has to do is figure out why. Peter, we've been talking to a number of people. There are a number of theories, all of them speculation. Let me run down a few of them for you, if I may. One possibility, perhaps one of the 3 main engines simply let go, causing a problem that way. These engines had flown before, all 3 of them. One of them on 3 missions, one of them on 4 missions, the other on 4 missions. Perhaps something happened to an engine. Another possibility, perhaps there was a problem in the fuel line connecting the tank to the shuttle Challenger. Maybe something happened there. Another problem, perhaps it was one of the struts, one of the connectors holding that big tank onto the shuttle. Maybe that was the problem. Another possibility, a puncture in the tank. That tank, again, extremely thin-skinned, the orange tank. Maybe there was a hole, maybe there was a leak, who knows. The only other possibility, and I'm sure there are millions more, the only other possibility I've heard discussed was that one of those boosters, one of those white crayon-like structures on the side, those big Roman candles, perhaps went awry before it split off. Our evidence from the footage we've seen does not seem to indicate that. Again, we're not going to know until they do all the analysis.
Well, Lynn,
those are, again, just some of the theories.
Well, I'm just saying, just by suggesting some of the theories, you've opened an endless range of possibilities. One of the people who's been tremendously helpful to us today joins us again now from Houston, Gene Cernan, the former Apollo astronaut, the last man to walk on the moon. Gene, you've seen the same tapes over and over again today. What do they tell you?
Well, Peter, you know, we can speculate, I guess, all day long, but it does appear that something, Lynn's ideas are certainly have potential, but it appears to me that whatever it was, it violated the integrity of that tank and allowed the liquid hydrogen and the liquid oxygen in some capacity to mix. And hydrogen is a tremendous explosive, and in this case, we saw the results of what can happen when it's mixed with something like oxygen.
Well, Gene, let me offer, if I may, to you another theory, if I could get a look at this model here. Correct me if I'm wrong, but about a year ago, the whole process was lightened up to some extent. And there was some suggestion today, at least by some people, that these struts, and Lynn has alluded to it, these things which basically hold the Challenger on to this enormous gas tank, which is really what it is, may have not been able to stand the stress. Do you buy that theory at all?
Well, of course, that's always possible, but you know, the vehicle was designed to go through that area we've talked so much about today called maximum dynamic pressure. That's when, if you will, the speed of the aircraft and the density of the air create the greatest wind on the spacecraft during its ascent. It's designed specifically as for that point being a high stress point, where you get the greatest shaking, the greatest bending of the skins, the greatest flapping of the wings, if you want to go to exaggeration. That's a very critical point. It appears that this either occurred just subsequent to that point. There may have been a rupture as a result of that through fatigue or for some other reason.
Gene, there has been the obvious question asked today about an escape mechanism in a space capsule or something on board the shuttle. There was one on Columbia some time ago. Why not on Challenger?
Well, you know, the Columbia's first 4 flights, I think the crew, it was only a 2-man crew. They did have ejection seats. It was a test vehicle. If we go into history of the space program, no other manned spacecraft has been flown for the first time with a man aboard. They were all flown unmanned until we got to the space shuttle. We built ejection seats in so that the crew was able to make some decisions at different points of the missions had they needed to, had they had some inkling of a problem that was forthcoming. We decided when we put 5 and 6 and 7 people on and the shuttle became more operational, proved its capability, its reliability, that not only was there no need for those ejection seats, in a case like this, for instance, they would not have even done any good. There was an escape mechanism, and that was a shuttle itself. If the crew, if the ground had some idea that there was a problem occurring, a critical problem, even a couple moments ahead of time, they could have jettisoned that external tank, jettisoned those solid rockets, and although the maneuver is very complicated and difficult, landed back at Kennedy Space Center.
Gene, I'd like to point out, and I know that you know this too, of course they have that capability. As you well know, nobody really ever wanted to try that. A return to the launch site abort, which is the technical name for it, that emergency landing back at the Cape, they say they were prepared for it. They didn't really ever want to try it. And just to add to what you were saying about the ejection seats, Peter, you're quite right. There were ejection seats on Columbia. There are no longer. It has been modified to match Challenger, Discovery, Atlantis. And as Gene points out, there were only 2 ejection seats, and now there's 5, 6, and 7 passengers.
Well, I think the point I'm trying to get at here, because it has been raised today, and let me get a fairly brief answer from you, if I may, Gene. Was this a shortcut because we were putting additional personnel on the shuttle, or is this a reflection of how good NASA felt about the safety of the program in general?
No, the program was designed to follow this this plan of attack. It was designed as a test article and a test vehicle initially to have those ejection seats. Subsequent to that, it was designed not to have them, and that was the plan. This was not a shortcut. It was just a planned and a long-term operation of this vehicle. You know, if I might refer to something Lynn said, she's absolutely right. Nobody ever wanted to make that abort and come back to landing site. A very difficult maneuver for the best aviator in the world. But we confronted those things a lot in the past. My last launch was a night launch. If everything failed and we had to abort during the same phase of the mission and we had to get off the launch vehicle, at nighttime I had to use STAR to be able to orient the vehicle so that we could head in the right direction and not burn up coming into the atmosphere. That's something I didn't want to do, but it's something we practiced, and I think indeed I knew we could do it if we had to, and I believe that was the same in this particular case in every shuttle flight.
Gene, thank you very much for joining us. You've made a wonderful contribution today, and we're very grateful. You helped our understanding a lot. Gene Cernan, last man to set foot on the moon, one of the Apollo astronauts who has become, as we said at the beginning of this program, the nation's astronaut, one of those individuals who has been so touched. One of the things that people have said fairly regularly today is that we've become rather blasé about the success of the manned space program. On the other hand, people have tended to refer on more than one occasion to the way people chivied away at NASA because both Columbia and Challenger have spent additional time on the ground when they were supposed to be launched because of minor and sometimes not so minor problems. There's no question that both Columbia and Challenger's the issue here today, was something of a troubled spacecraft. Does not suggest by any means reflection on what happened today, but it was, on occasion, a troubled spacecraft. Here's John McAuliffe.
When they built this $1.5 billion spacecraft, they projected that it would be flying for at least a decade, part of a fleet of space shuttles that would be roaring into orbit every few weeks. Challenger was on its 10th flight today, and just its 3rd year of service. Like its sister ships, Columbia, Discovery, and Atlantis, Challenger has suffered through some crippling technical problems over the years, but has also repeatedly written itself into the history books with its many successful firsts. It was aboard Challenger that Sally Ride, the first female astronaut, made her maiden voyage into space. Guyan Bluford became the first American black in space. His ship was Challenger. The spacecraft was used for the first spacewalk from a shuttle in 1983, and a year later it proved for the first time that shuttle could indeed capture a satellite, repair it, and send it back into orbit. But Challenger has also been shadowed by problems. Its first launch in 1983 was delayed for 2.5 months because of an engine leak. In one 1984 mission, the Challenger crew lost 3 satellites while trying to launch them into orbit. Malfunctions later blamed on the satellites, not on Challenger. In December of 1984, NASA had to scrub Challenger's next mission. It was supposed to carry the military's first secret payload into space. Challenger's protective heat shield had been badly damaged, and the ship had to go in for an extensive overhaul. Last July was probably Challenger's worst month until today. 3 seconds before its scheduled liftoff, the countdown was stopped because of a coolant leak.
We have an RSLS abort. We have an abort.
Later that same month, Challenger came perilously close to disaster when it suffered what NASA called a launch emergency. One of its engines shut down while the spacecraft was climbing into orbit. The crew scrambled to jettison excess weight, but they could never get Challenger up to its full orbit. Challenger was supposed to fly 5 missions this year. One of them was to be a secret military payload, taking it into orbit. The military, in fact, has been so concerned about the reliability of Challenger that it has insisted that NASA fly at least 2 military payloads a year the old-fashioned way atop expendable rockets. That was a hedge in case the Challenger and all of the other space shuttles proved that they could not do as promised. Peter?
John, thank you very much for joining us. In fact, on the 4 shuttles, there were 15 missions planned for 1986, both in the commercial field and the military field. This was to be a very ambitious year for the space shuttle. And as John McAuliffe points out, and as others have pointed out, this is an enormous setback, not only for the commercial competition, but also for the military program, which the United States had been using the shuttle for. In a sense, we'd like to put aside for a moment now the technical dilemmas for today of Challenger in this particular instance and the overall program, and talk about the human dimension, because as those of you all around the country must have felt, and we have been quite stunned, I must tell you, to hear and feel and sense the reaction from all around the world. It came from China, it came from the Soviet Union, Her Majesty the Queen in Britain, the National Parliament in Canada took a minute of silence. There was this quite incredible outpouring of sorrow and shock from around the world for the 7 individuals on board.